list of numbers called terms separated by commas. One thing that is different from this unit, from all the other units, is the domain. It's not a continuous domain. The domain is whole numbers. Okay? 1, 2, 3, 4. It's a list of numbers. And so there's no in between. You have the first term, second term, the third term. Whole numbers. Now, I'm going to include 0 because depending upon what book you look at or how you define your sequence, sometimes they start the counter at 0. And so this would be 0, 1, 2, 3. There are no negative inputs. Remember, domain is your input number. And in this particular unit, we're going to use n as our input instead of x. The term, that's what we're going to call the output, is the actual number in the list. A sub 1, and our input is going to be the subscript number. The term is the output. A sub 2 is the second term. Notice where the input is. The input is the subscript. A sub n, both pieces together, is the output. A sub n, the nth term. And we have two others here. A sub n minus 1. That just means previous term to a sub n. It's the one that comes right before it. Previous term to a sub n. Okay, a sub n plus 1, the next term. So here is an example of a sequence, which is a list of numbers separated by commas. And we're going to write down a sub 1, a sub 2. A sub 1 means 5, the first term. Notice that you're not going to see the input number. You just have to count how many terms in the list. So a sub 1 refers to the first term in the list. You're not going to see the 1. You have to count to figure out which placement it is. A sub 2. A sub 6. 1, 2, 3, 4, 5, 6. It's different than what you've done before with the function notation. You're not always going to see the input. You're going to have to count it out to figure out where the placement is. Now, we're going to look at two very specific patterns. Okay? An arithmetic pattern and a geometric pattern. An arithmetic pattern is a pattern that uses add or subtract to get from a sub n, one term, to the next term. Add or subtract. That's the key word here. Arithmetic means add or subtract pattern, because we're going to have to name the type of pattern we're looking at. The common difference is called D, right? It's just a letter. Okay. Is the number added or subtracted? Common difference. Usually call that one D. Okay, here's your example. What's the first term? 93. Okay, what's the common difference? Look at the pattern and determine what the difference is.
4.
Almost. -4, because it's decreasing. And so when I look for my patterns, I look at how to get from the first term to the next term. -4. Make sure that pattern stays consistent. And so the common difference is -4. I'm going to write a formula here. Can anyone tell me how to find the common difference? Question?
Is the graph going to be linear?
Yes. The graph is going to be linear. So I'm going to just sketch these points here. The first term is 93. The second term, 1, 2, 3, 4, 1, 2, 3, 4, over 1. 1, 2, 3, 4, over 1. It's linear. You're going down by 4 every time. And so that's a good observation. The graph is linear. But notice, guys, I'm not going to draw a line because the domain is not continuous. The graph of a sequence is just a bunch of dots. That's it. 1, 2, 3. And it goes down by 4 every time. And so I'm going to put a little note here. The slope is -4. Because that's how I count. Over 1, down 4. Over 1, down 4. All right, what about a formula for the common difference? Formula would be using one of these up here. How do you find it? Okay, so I'm going to give you a placeholder. Common difference equals, what two things do you subtract to find the common? Yes? Yes. A sub n minus A sub n minus 1. The previous one. So let's try it. Let's see if that works. Okay. 89 minus 93. 89 minus 93. Yes. So you subtract consecutive terms. Subtract consecutive means next to terms. Okay, let's do geometric pattern. Right? We're only going to do 2 specific patterns here. Geometric pattern is a pattern that uses multiplication to get from a sub n to a sub n plus 1. I did not say divide on purpose. It's not part of the definition. just multiplication. This particular pattern has something called a common ratio. Common ratio is R. Okay? Is the number multiplied okay, so if I look at the example, the first term is 240. But what's the common ratio? And so I look at it. What do you do to get from one term to the next term? Multiply. I didn't say divide by 1/3. I said multiply by 1/3. And so the common ratio is 1/3. Okay, so let's look at it. I need to figure out, how do I actually find this common ratio? Okay, so look at your example. How can you come up with 1/3 by just using these numbers in the list? What two numbers do you divide? Gray? So this term, 80, divide by the previous one. Yeah. Make sure that this is previous to the one on top. So let's try it. A sub n. A sub n could be any placement on the list. This just means the one right before it. So this is 80 over 240. 1/3. Oh, what's that graph going to look like? So let's see if we can just plot. 1, 2, 3, 4. I'm going to try to give this a little bit of scale. Hold on a second. Give people. Okay, so I'm going to count by 50s. So the first one is like way up here, counting by 50s. The second one is like here. 80 over 3 is like 20-ish. 80 over 9 is like this. Ooh. What does it kind of look like? What does it look like?
Indirect relation.
Okay, it kind of looks like inverse relation. Oh, yes. It's closer to something else. Exponential decay. It's exponential. It's exponential. Now I'm not going to, this particular one is decay. I'm not going to be specific because I could switch the pattern around and I can make it go up. So the graph is exponential. Because if I keep going, I do get an asymptote on this particular graph because that number gets smaller and smaller, but never 0. All right, last type of pattern is recursive pattern. And this is a pattern that uses previous terms to define it. The most famous one is the Fibonacci sequence. There we go, sorry. 1, 1, 2, 3, 5, 8, 13. Can you fill in the next 3 terms? Can you find the pattern? Okay, just look for a pattern. Now I put it separate from arithmetic and geometric because it doesn't have to be an add or subtract pattern. It just has to find a pattern. Can you find the next three terms? Okay. Raise your hand. Who can tell me the first missing number? Yeah.
21.
21. How did you get 21?
8 plus 13.
8 plus 13. So you added the two previous terms. Okay? A pattern that uses previous terms to define it. I had to look at the list. Okay? 8 plus 13 is 21. 13 and 21 is 34. Recursive means you have to use the previous terms in the list to actually find the next number. 55. Okay. Almost there. I know it's a lot of vocab. An explicit rule relates the input n to the output a sub n. And this is an equation. It could be a linear equation. It could be an exponential equation. It's an equation. A recursive rule relates the previous terms to the next term. I'll put parentheses, previous terms to the next term. Notice that this doesn't have to do with the input. It has to do with just the outputs. This is connecting output to output. I actually have to know the numbers in the list to do this recursively. Okay, finding patterns. Using the given rules, write the first 5 terms. So a sub n equals 3n minus 1. Remember that a sub, that's the output. The n is the input. So the first term means plug in 1. The second term, 6 minus 1, is 5. The subscript tells you the input. A sub 3. 9 minus 8. Okay, stop at 3 terms. What's the pattern? Say it again. Add by 3. Add by 3. Takes 3 terms to find a pattern. Plus 3. So I'm going to come up here. I'm going to write common difference is 3. I call it D because this is an add pattern. Would I plug in 4 and 5? No. Why not just add 3? I already found the pattern. Why not just use the pattern to find the next terms? 11 and 14. Okay, let's try first term, second term, third term. Once you find the pattern, try to find the next 2 terms without plugging in. It's okay to use a calculator, guys. This is a calculator unit because there's a lot of big and small numbers that you do not need to do by hand.
That's 0. 1 after a 0. Because 1 minus 1 is 0.
first term. Okay, so I notice that this is a times 1/2. Okay, ratio 1/2. Notice by using the correct letter, I've already categorized this as arithmetic or geometric. Okay, now the last one, oh, that's different. That's what a recursive formula looks like. Notice how it's relating the previous term to the next term. Notice that the n is a subscript. Here, the n was not a subscript. Okay, so I'm going to start my list with 8. And then I'm going to say a sub 2. And instead of saying a sub n minus 1, I'm going to say previous. So this equals 2 times previous a sub 1 plus 3. Now that means I have to use the list, the number in the list. So this is 2 times 8 plus 3, 16, 19. And so the second term is 19. A sub 3. 2 times the previous term plus 3. Well, that's 2 times 19. I'll put some grouping symbols in here. Plus 3. Yes?
So for a for an, why would it be why wouldn't you just substitute in why would you substitute in 7 because 8 minus 1 is 7?
No. I'm not subtracting 1. Look at, it's a subscript. I'm changing the counter. Okay, so if I plug in 2, well this comes from here, right? If I plug in 2, a sub 2 minus 1. 2 minus 1 is 1, which is a sub 1. So I'm changing the subscript number. When I plug in 2, I'm changing this number, which is not the output, right? It's just the index, the counter, the input number. And so a sub 1 is 8. So notice I'm using the previous number in the list. So a sub 4 is 2 times the previous number plus 3. It is easier to say previous or next instead of trying to look at the subscript. N minus 1 is the previous term. The previous term. 82, so 85. So the fifth term is times the previous plus 3. 160, 170. Okay, let's take 4 minutes and see how many of these next 4 questions you can do. All right, volunteer, I need the first term for D. Yeah, Ben. -2. Second term? -6. -10. -14. Yeah, once you find the pattern, use the pattern. Okay, somebody else, first term for E. Anybody else? Yeah.
4.
4, yes.
Then -12.
Yep.
And then 36.
Okay. All right, so I look at this, And I notice that the ratio is timesing by -3, and so then I get -108. You don't always have to plug it in once you find the pattern. Here, I notice that the common difference is -4. Okay, now for the good ones. Find the sixth term. Well, I'm going to start with my first term, so that's 20. My second term is 20 times a half. My third term is 10 times a half. Okay, 3 terms makes a pattern. Use the pattern. This is a ratio of 1/2. 4th, 5th, 6th. 5 halves. 5 fourths. 5 eighths. Times 1/2. Okay, 6, that wasn't so bad, right? I can write 6 numbers pretty easily. It's like a handful of terms, do it by hand. Okay, well, we'll go 10, that's all right. But 25, that's a lot of numbers to write out. I want to write out 25 numbers. And so I'm going to start by finding the pattern. 17 plus 5, right? Because it's previous term plus 5. 22, previous term plus 5. 27, ... Okay, the common difference is 5. All right, I can add 5 pretty easily. I mean, I could add 5 a bunch of times in my calculator really quick. But how many times do you have to add 5 to get to the 25th term? 24. Okay, notice to get from the first to the third term, I only have to add it twice. To get to the fourth term, I only have to add it 3 times. And so, to get to 25th, add 5 24 times. 120, no, 100, plus 120. Okay, so 17 plus 120, so we get 137 as our 25th term. Am I going to stop you from adding 5 24 times in your head? No, that's fine. Okay? I'm not going to tell you you have to do it the faster way. You just need to be able to find it and recognize your patterns. Now, I told you that we have 2 very specific patterns. We do. It's an arithmetic pattern, and this is the explicit and the recursive rule. This is explicit. This is recursive. Notice that this one references the previous term, and this one, input to output. These are the formulas. You do not have to memorize them. You just have to be able to use them. Okay? So write the explicit and recursive rule for the following arithmetic sequences. Now I look at my formula. I need the first term. A sub 1 equals 50. I need the common difference. Minus 6. And then I plug it into the formula. Okay, so I'm going to write my formula. A sub n equals. I'm going to write mine in this format. It's point slope form. That's what it is. Notice that the D is the slope. It's point slope form. It's the first term and the first input. Okay, and they always go together. Okay, so plug it in. A sub n equals the common difference plus 50. Can I write this out? Sure. Minus 6n plus 56. This is your explicit rule. Yes.
Will we be given the formula?
Yeah, you will. But notice the pattern is linear. What if you were to count backwards to the 0 term? What would the 0 term be? What comes before 50 in the pattern? 56. The y-intercept? It's linear graph. That's the first term. Means the 0 term would correspond to the y-intercept. 56. What's the slope? Minus 6. Do you have to use the formula? No, you can just write an equation. Okay. Now, this also says recursive. So, a sub n. All right. What do you do to get from one term to the next? You minus 6. A sub n minus 1 minus 6. That's the recursive. You just tell me how you get from one term to the next. You subtract 6. That's the recursive formula. Previous term, common difference. Okay, a sub 1. Oh, they already gave me all my information. A sub n equals. Now I'll write it like this. A sub 1 plus n minus 1 common difference. 30 plus. Notice that you're leaving the n and the a sub n. Input, output, leave them. Plug in the other numbers. Minus 30 minus 3 halves. 57 over 2? Yeah, 57 over 2. Okay, try the last one. I don't give you the first term, but maybe you could find it. I'll give you a little. Right, that's what I do know. I know the third number is 10. How can you find what you need? How would you get from here to here the first time? Now they're telling me what my pattern is. So what number is going to go here in order to do this to get to 10? $14, yeah. 14, 12. Okay, So a sub 1 is 14, and my common difference. So 14 n minus 1 times negative 2. The recursive rule okay. We're going to stop at example 3, right? We're going to flip it over, and we're going to do a little bit of geometric so that we can take a break and do some matching. So when you're ready, turn it over, and we're going to look at example number 7. The two formulas are right there. See if you can pick out the information you need. Okay. Okay, so here we go. We got geometric. Okay, and minus 4. Okay, well it's not arithmetic because it's not a minus 4 pattern. You're like, I don't know how to get from 8 to 12. Okay, is it bigger or smaller? Depends upon how you think about it, yes? I think it is multiplied by 3/2, but let's look at how we could find it. Ratio. I don't know. I don't remember my formula. Okay, so let's try to do this. Negative 8 times the ratio should equal negative 12. Like, I don't remember that formula I wrote down. I was like, I divide something, but I don't know which order to divide it in. And so look at the things you have in front of you. Negative 8 times my ratio should equal negative 12. So what's my ratio equal? Yeah, negative 8 or negative 12 over negative 8. And reduce. Oh, it's the next term divided by the one before it. Okay, so we get positive 3/2. So now that I have my ratio and my first term, now I can write my rule. Okay, so this says a sub 1, and I'm going to put my ratio in parentheses. It's exponential. See the a, the b, and the exponent? Okay. A sub n equals negative 8, 3/2, and minus 1. There's no simplifying. That's it. That's it. We can't multiply the stretch number and the base together. You cannot do that. Okay, recursive. A sub n minus 1 times 3/2. Good. Picking out two numbers. First term, pattern. Ooh, okay. Sometimes you got to do a little bit of work to get to the first term. Okay. Last one. A sub n, first term, ratio, n minus 1. I'm going to write this because I remember my exponent rules. That one I could put together because the bases were the same. It's not necessary, but it could happen. Recursive, a sub n times 1/2.